The National Electrical Code, or NEC, does not explicitly state a minimum required distance between a transformer and a swimming pool in either Article 680, which covers swimming pools and fountains, or Article 450, which addresses transformers. However, the NEC does offer general guidance that is relevant to this situation. Article 110.26 P1 prohibits the installation of electrical equipment within 5 feet of a pool or spa. Furthermore, Article 680.21 C1 requires that any electrical equipment that is located within 5 feet of a pool or spa to be specifically designed and installed in such a way as to prevent water from entering or accumulating within the enclosure. Beyond the NEC requirements, several safety considerations should be carefully evaluated when determining the placement of a transformer in proximity to a swimming pool. Firstly, there is the potential for electrical shock. Transformers are capable of producing high voltages, so a significant risk of electrical shock exists if water were to come into contact with any of the live or energized parts. Secondly, arcing and fire hazards should be considered. If water manages to enter a transformer enclosure, it can lead to arcing, which in turn can cause potential fires. Thirdly, water can cause significant damage to the transformer itself and to other connected electrical equipment. Considering these safety factors and the absence of specific distance mandates in the NEC, it is generally recommended to maintain a minimum distance of 30 feet between a transformer and a swimming pool. This 30-foot distance acts as a buffer zone, substantially reducing the risk of electrical hazards and potential equipment damage. However, if maintaining a 30-foot distance is not feasible due to space constraints or other site-specific limitations, you should carefully consider implementing alternative measures to enhance safety. One such measure is to use a transformer that features a waterproof enclosure. This type of transformer is specifically designed to withstand water ingress, offering a higher degree of protection against moisture-related failures. Another option is to elevate the transformer. Installing the transformer on a pedestal or platform can raise it above the potential reach of water, thereby mitigating the risk of submersion or splashing. You could also install a safety barrier. A physical barrier, such as a fence or wall, can be constructed to keep people and water away from the transformer, providing an additional layer of protection. In conclusion, while the NEC does not explicitly specify a minimum distance between a transformer and a swimming pool, adhering to a minimum distance of at least 30 feet is highly recommended for safety purposes. If maintaining this distance is impractical, it is important to carefully consider and implement alternative measures to mitigate the potential risks of electrical hazards and equipment damage, ensuring a safe environment around the swimming pool. Always consult with a qualified electrical professional to ensure compliance with all applicable codes and regulations and to implement the most appropriate safety measures for your specific situation. Remember that electrical safety is paramount, especially in areas where water is present. The recommendation of a 30-foot distance is based on general safety principles to minimize risk. A qualified engineer should be consulted to evaluate site-specific conditions, conduct a thorough risk assessment, and determine the most suitable and safe transformer placement. Factors to consider during the assessment include but are not limited to soil conditions, drainage patterns, the presence of other utilities, local climate, and any applicable local regulations that may impose additional requirements beyond the NEC. The type of transformer also matters. Dry-type transformers and liquid-filled transformers have different characteristics and safety requirements. Liquid-filled transformers may pose additional environmental concerns related to potential leaks. Ensure that the selected transformer is appropriate for the intended environment and application, and that it meets all relevant industry standards. Regular inspections and maintenance are critical to ensure the continued safe operation of the transformer. Develop a maintenance plan that includes periodic visual inspections, testing of electrical connections, and assessment of the transformer's overall condition. Address any identified issues prompted to prevent potential hazards. Ensure that all personnel who may come into contact with the transformer or the surrounding area are properly trained in electrical safety procedures. This includes recognizing potential hazards, using appropriate personal protective equipment, and responding effectively to emergency situations. Always de-energize the transformer before performing any maintenance or repairs, and follow proper lockout-tagout procedures to prevent accidental energization. The grounding system is a critical safety component of any electrical installation. Ensure that the transformer is properly grounded in accordance with the NEC and other applicable standards. Regularly inspect the grounding system to verify its integrity and effectiveness. Consider the use of ground fault circuit interrupters, or GFCIs, to provide additional protection against electrical shock hazards, especially in areas where water is present. GFCIs are designed to detect small ground faults and quickly de-energize the circuit, reducing the risk of serious injury. Proper signage is essential to warn people of potential electrical hazards. Install clear and conspicuous warning signs around the transformer to indicate the presence of high voltage and to advise against unauthorized access. Ensure that the signs are weather-resistant and easily visible, even in low light conditions. Electrical codes and standards are constantly evolving. Stay up to date on the latest requirements and best practices by participating in industry training programs, attending conferences, and consulting with qualified professionals. This will help you ensure that your electrical installations are safe, compliant, and reliable. Obtaining the necessary permits and approvals from local authorities is essential before installing or modifying any electrical equipment. This will help ensure that your project meets all applicable codes and regulations, and that it is properly inspected and approved by qualified professionals. Consider engaging a qualified electrical contractor to perform the installation work. A qualified contractor has the knowledge, experience, and equipment necessary to perform the work safely and correctly. They can also help you navigate the permitting process and ensure that your project meets all applicable requirements. Always prioritize safety when working with electricity. Follow all safety procedures and use appropriate personal protective equipment to prevent electrical shock and other hazards. If you are not comfortable working with electricity, seek the assistance of a qualified professional. Proper planning and design are essential to ensure the safe and reliable operation of electrical equipment. Conduct a thorough load analysis to determine the appropriate size and type of transformer for your application. Consider factors such as voltage, current, power, and load characteristics. The location of the transformer should be carefully considered to minimize the risk of environmental hazards such as flooding, corrosion, and exposure to extreme temperatures. Choose a location that is well ventilated and protected from the elements. Consider the use of surge protection devices to protect the transformer and other electrical equipment from voltage surges caused by lightning or other events. Surge protection devices can help prevent equipment damage and reduce the risk of electrical fires. The electrical equipment should be inspected regularly for signs of damage or deterioration. Look for things like cracked insulation, loose connections, and corrosion. Replace any damaged equipment immediately to prevent potential hazards. Keep the area around the transformer clean and free of debris. This will help prevent fires and other hazards. Ensure that there is adequate clearance around the transformer to allow for proper ventilation and maintenance. Use the correct type of wiring and connectors for the application. Ensure that all wiring is properly insulated and protected from damage. Avoid overloading electrical circuits. Overloading can cause wires to overheat and create a fire hazard. If you are unsure whether a circuit is overloaded, consult with a qualified electrician. Never tamper with electrical equipment or attempt to make unauthorized repairs. The electrical work should only be performed by qualified professionals. If you have any questions or concerns about electrical safety, consult with a qualified electrician or electrical inspector. They can provide you with expert advice and guidance. Remember that electrical safety is a shared responsibility. By following these guidelines, you can help ensure a safe and reliable electrical system. Consider a risk assessment matrix which evaluates both the likelihood and severity of potential hazards associated with the transformer's location. This matrix can help prioritize risk mitigation strategies. Soil resistivity testing can determine the effectiveness of grounding systems in the specific location. Low soil resistivity is crucial for effective grounding. Thermal imaging can detect hotspots in the transformer, which can indicate potential problems such as loose connections or insulation breakdown. Regular thermal imaging can help identify and address these issues before they lead to failures. Consider the impact of electromagnetic fields, or EMF, generated by the transformer. While the health effects of EMF are still debated, it is prudent to minimize exposure, especially in areas frequented by people. Shielding materials can be used to reduce EMF levels. Regularly review and update your safety procedures and training programs to reflect changes in technology, codes, and best practices. This will help ensure that your personnel are always equipped with the latest knowledge and skills. Document all inspections, maintenance, and repairs to provide a record of the transformer's condition and any actions taken. This documentation can be valuable for troubleshooting problems and demonstrating compliance with regulations. Consider the use of remote monitoring systems to track the transformer's performance and detect potential problems early. Remote monitoring can provide real-time data on voltage, current, temperature, and other parameters. Develop an emergency response plan that outlines the steps to be taken in the event of an electrical accident or equipment failure. This plan should include procedures for notifying emergency services, evacuating the area, and shutting down electrical equipment. Conduct regular drills to ensure that personnel are familiar with the emergency response plan and know how to respond effectively. Review the emergency response plan periodically and update it as needed to reflect changes in the facility or equipment. Establish a communication plan to keep all stakeholders informed of electrical safety issues and concerns. This plan should include procedures for reporting hazards, providing updates on safety initiatives, and soliciting feedback from employees and other stakeholders. Conduct regular safety audits to identify potential hazards and assess the effectiveness of your safety programs. Safety audits should be conducted by qualified professionals who are familiar with electrical codes and standards. Implement a system for tracking and resolving safety issues identified during audits and inspections. This system should ensure that all issues are addressed promptly and effectively. Foster a culture of safety within your organization by promoting open communication, providing regular training, and recognizing employees who demonstrate a commitment to safety. A strong safety culture can help prevent accidents and injuries and improve overall workplace morale. The 30-foot recommendation serves as a practical guideline, but site-specific evaluations may justify deviations when coupled with enhanced safety measures. Proper engineering oversight is crucial to adapt general recommendations to the specific characteristics of each installation site.